There are three distributions that come up quite a bit in a intro to statistics class, and they are the normal curve, the student's t curve, and the chi-squared curve. So we're going to take a look at these and their standard shapes and where they might show up. The normal and student's t distribution, the normal is sometimes called the z distribution, student's distribution is sometimes called the t distribution. Both follow a typical bell shape. So that's going to be a symmetrical unimodal curve where we have a single peak in the middle. Data is distributed pretty evenly on both sides. The main difference between the two is that the t distribution has a little bit more area under the tails and a shorter peak. The z distribution is going to have a little bit taller peak. But for the most part, these two are very similar, and we'll take a look at the details of that in a second. Chi-squared has a few different versions of that graph depending on the size of the sample you're working with, but typically it's thought of as a curve that is a little bit skewed. So you might see something like this where most of the data is pushed off to the left here closer to one endpoint, and the other end seems to go out for quite a ways. So continuing on with chi-squared, I'm on the Wikipedia page for chi-squared, and you're going to see that it has quite a bit of stuff, and a lot of it is going to be Greek and or dense. So we're going to skip over some of that and just try to get the basic idea. Over here you see the probability density function. Basically this is the shape of the graph. If you were to make a histogram out of data that followed a chi-square distribution, it would follow one of these curves. And each of these lines represents different sample sizes that you're working with, so different amounts of data that you would have. You'll notice that for the most part, with the exception of a few of these curves, they kind of follow this lumped up version where they shoot up right away and then kind of slowly trail down. So it's going to be some sort of skewed graph. Now the chi-square distribution is usually used for statistical tests that we'll do later in the semester. So it's not going to pop up a lot with what we're looking at now, but we might talk about it as a somewhat skewed distribution. The normal curve is something we will see quite a bit though. The normal curve is that standard bell shape, and here you can see a few different normal curves. But let's go down to the applications. The normal curve pops up all over the place. One of the major areas that we see it is in things like height or any kind of measurements of biological things. So if you separate by male and female, because male and females are going to have different weights and heights that are kind of standard in populations, you separate by that, you're going to start to see things where most people are at this peak in the middle, and then it kind of trails off on either side. Another area that comes up a lot is standardized testing. Anything where you are trying to get people to score kind of in the middle. You're going to have some people that trail off and on the very high end, some people that trail off on the very low end, and a lot of people in the middle. That goes for IQ testing as well. Another area that it does come up is this ball drop here. You'll see here you have a bunch of little pegs. If you were to drop balls from the very top of this and it would bounce between the pegs, you would start to see that the graph formed by that, if it fell into different slots, would follow roughly the normal curve. Now, if any of you have watched The Price is Right and seen the game Plinko, it has the same basic effect. Most of the balls are going to fall into the center slot because it could bounce left, then back right, it could bounce right, then back left, and continue to fall in here. The only way it's going to make it all the way to the far end is if it went left, 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 all the way every single time. So there's more possible paths to get to the center, which is why more data ends up there. But that follows roughly a normal curve. So there's a handful of things in nature and in the human world that do that. So the student t distribution is very, very similar. The primary difference is that instead of using population data, instead of knowing things about the entire population, such as, oh, we know that the average height of all Americans is this and the standard deviation is that. Instead, whenever we just have a sample of data, I collected data from 10 people today, and here is the average height and here's the standard deviation. Whenever we have situations like that where we're just collecting small amounts of data, we're always going to use the student t distribution. The reason we do that is it is a little bit better at estimating for us when we don't have the entire population's data. Scrolling down, you're going to see these graphs here on the page. The blue curve represents the normal curve, the z distribution that we talked about earlier. And when you have a sample size of 2, which means 1 degree of freedom, we'll get into what that means later, you'll see that the t-curve here has more area in the tails and has a shorter peak. As you get more and more numbers in your sample, the red line here is getting closer and closer to the blue line. The peak is getting a little bit closer to that blue, the tails are getting a little bit shorter. These green lines just represent the past lines that were drawn. And by the time you get to 30 degrees of freedom, which represents a sample size of 31 subjects that you sampled, you would end up with something where the normal curve and the t-distribution start to get very close to each other. They're not quite touching yet, but they're getting closer and closer. So again, to reiterate, the normal and student's distribution are these roughly bell-shaped symmetrical unimodal curves, and the chi-square distribution, although there's a few versions of that as well, we typically like to think of it as something that is a skewed right curve with a big lump of data over on the left side.